So, hello to you, sir. Today I'm going to be explaining about the third lab for this semester, which is under fluid dynamics in specific control volume. My name is Sakthyvel Alaggan, and the main title of this experiment is going to be Impact of a Jet. So, as an introduction, to analyze fluid motion, a finite region of the fluid, also known as a control volume, is usually selected, and the gross effect of the flow, such as its force or torque of an object, is determined by calculating the net mass rate that flows into and out of the control volume. So, control volume is just a region that we choose where the fluid flows. And the equation that we used in this is the momentum equation. There are two objectives to this experiment. Firstly, is to investigate the reaction forces produced by the change in momentum of fluid flow when a jet of water strikes a flat plate or a curved surface, using the momentum equation as what I've explained before. To compare the results from this experiment with the computed forces by applying the momentum equation. So in this experiment, there'll be a theoretical value and an experimental value. And one of the objectives is to compare the results and see which is more accurate. So this is the setup, this apparatus, as you can see on the left side. That is the impact of a jet apparatus, which has a nozzle and a target plate, which is the two main parts of the apparatus. The water will flow through the nozzle and hit the target plate. As I explained earlier, there'll be two target plates. One is a hemispherical one, and one more is a flat one. And on the right is the apparatus used, which is a hydraulic bench, a jet apparatus, as what it says there, and a stopwatch for timing of the measurements. For the procedure, it's fairly simple. The apparatus was leveled and set the lever to a balanced position. Water through was admitted to the supply valve, and flow was increased to the maximum. Flow rate was established by collection of water over a timed interval. 8 readings were recorded as the flow rate reduced. Steps were repeated twice for flat plate and hemispherical cup. From there, this is what we get. On the left is the values for the flat plate. On the right is the values for the hemispherical cup. From there, we get this graph, which, as you can see, has the experimental values and the theoretical values, which are somewhat similar um, for the experiments. As you can see, even in the results table, there's a experimental force and a theoretical force, which is F1 and F2 respectively. So the discussion, as the flow rate increased, the force resulted from the impact of the jet on both the flat plate and the hemispherical cup is increased for the predicted F1 and the measured F2 values of the force. This relation can be seen clearly from the four plots accompanied with this report. This result was already predicted from the change in momentum equation of calculating the force. Some errors that might have occurred are errors in taking readings, which might have hindered the overall accuracy of this experiment. So, in conclusion, the jet impact of the jet forces of the flat plate were half of it in on the hemispherical cup. This result is displayed clearly in plots 1 and 2 for both predicted and measured values of the force. This was already predicted from the equation of momentum for calculating the forces. According to the last point in the hemispherical cup, is more efficient for using in a turbine than the flat plate. But only one point to be considered is that the water to exit the cup is going to collide with water entering up, which will reduce the force. That's about it for my explanation. Hope this was clear enough. Thank you and have a good day.